Hello there, welcome. Let's continue the tutorial on our permutation. This is episode number 10, and I believe you have watched the previous episode to where we are. If you have not, feel free to go back to the YouTube channel, locate the playlist, permutation and combination, and you can get all the episode. Don't forget to subscribe, like the video, and leave a comment after watching. The number of numbers lying between 40,000 and 70,000 that can be made from the digit of 0, 1, 2, 4, 5, and 7 if digit can be repeated in the same number is what? We have, I think in the fifth or seventh episode, we have a similar question whereby the digits are not repeated. So if the digits are not repeated, we have a way by which it is being done. Then in this case where the digits can be repeated, it means that we can have 44444 being the numbers, right? So first thing first, let's find how many numbers that we can be able to form from this word number. So we can say that the numbers, they are of what? How many digits? 1, 2, 3, 4, 5. There are 5 digits. So if there are 5 digits, which digits are going among here can be the first digit between 40,000 and 70. You can see that 0, 1, 2 cannot be. 7 cannot be, because if 7 is here, it becomes 7,000, 70,000, which is not between. It is going to be exactly. So it means that we are going to be having 4, let's say, or 5 at the, what is that position? Ones, tens, 100, 1,000. So in the tens of thousands word place, or let's say position. So if these two numbers, these are only two numbers that we can alternate, then how are we going to arrange that? In how many ways can we be able to make the first digit, which is a 10,000 digit, to be either 4 or 5? Meaning there are two of those numbers whereby we can pick only one at a time. So that implies that I have 2 permutation 1, which will be the same as what? 2. Because if I have 2, permutation 1 is going to be 2 factorial. Let me just say 2 factorial on 2 minus what? 1 factorial, which will be 2 factorial on what? 1 factorial. And 1 factorial is also what? 1. 2 factorial is just 2. Because 2 times 1, that is why I just mentioned it is 2. Alright. Then what is next? We have taken the first position. So we are left with the other 4 position. So we can say that the remaining places, how many places are going to be left? We are having 5 numbers, so the remaining 4 places So we can say that the remaining 4 places can be occupied by the 6 given digit. Do you believe that? It could be 6 digit. They are going to have 5 digit numbers: 1, 2, 3, 4, 5. If I pick the first place, which will be either 4 or 5, so let's begin with 4. If 4 is here, then I am left with 1, 2, 3, 4. 4 places to pick. So these 4 places is what we are describing here. Then in these places here, which of these numbers that can be here? I've used 4. So if there is no repetition, it means 4 will not be used again. It could only be 1, 2, 3, 4, 5. But because there is a repetition, the 4 can appear here again. It could be 4, 4, 4, 4, 4 in all places. So 4 will still be available If 4 is going to be available, it will still make the numbers to be what? 6. So there are 6 digits to pick from. So remember the episode number 9 where we deal with permutation where repetition is allowed. We say that if repetition is going to be allowed, if I have n different objects to pick from, then I'm picking, let's say, r number of them. That simply means that I am having an exponent of the n by the r. What it means that this implies that the number of ways that we can fill the 4 places is going to be, we are picking the 6 numbers. If I pick, let's say, 4, it means 4 can have 8 numbers being repeated. First 4, I'll still be left with 4. The same number of digits, 6, still 4, they will be in all those directions. So that will give you 6 numbers, picking 4 of them. If you want to understand this carefully, we are dealing with repetition of the digit being allowed. Meaning, out of these 6 digits, the first option I can pick for this position will be 1, 2, 3, 4, 5, 6. Then for the next position, I still have in my possession 1, 2, 3, 4, 5, 6 numbers to pick from. Then in the next position, I still have availability of 6 different digits to pick from. So 6 times 6 times 6 times 6, 4 different places. 1, 2, 3, 4. 4 different places will give us this. I believe we are able to get that. Let's see what that multiplication will be. 6 exponent 4. That will be giving us 1,296. So even just the 4 remaining positions which we are going to be picking from all the 6 numbers will give you 1,296. So we can say that the required, let's see what will be the required number. We are dealing with 2. We are dealing with what? This 1,296. Remember the fundamental principles of counting. We need to multiply in these 2 places. Since we have 2 first as the first position, the remaining ones will multiply. So we have, therefore, the required number of what? Ways is going to be 2 times the 6 exponent 4. Now, if I do it this way and leave it like this, 2 times 6 exponent 4, what of if we have this number 0? The first digit is 4, right? Then the digit here, I am going to choose from all these 6, and it happened to be 0. Right? And in the third position, I am still supposed to choose from all these 6 while this is talking about this. Then it means that the possibility of 0 being coming could also be realized. How about the fourth position? I am still going to choose from all the 6. You can see, so I will still have 0. I may still have 0. Then the last position, since I am still left with all the 6 digits in the case of this, it could be 0. So that if this number can also be inside the 1,290, then it means that number is not between 40,000 and 70,000 to happen. So that number is not part. This very number. And how many are they? How many of them can we see inside? It can only be 1. The moment this one becomes 4, 0, 0, 0, and 1, 1 is going to be between 40,000 and that of what? 70. So it is not an outlier. But this alone is an outlier. So we subtract it from the total number that we are having. So we take away that one option, this very option, which is not going to be possible to be between 40,000 and 70,000. That one option is taken away. Then that will give us multiplying the 2 times 6 exponent 4, that should be giving you 2,592 minus 1. That will give us 2,591 various ways by which we can arrange or we can find numbers that are lying between 40,000 and 70,000. All right. Now, if you can check the previous episode, I think it will be in episode number 8 or so. Episode number 8. Then you compare that solution to this episode number 10. You see, in that episode, we still have the same everything. The only difference was repetition is allowed. In the previous one, repetition is not allowed. So the numbers you are going to get are not going to be this huge. But since there is a repetition, then the number is going to be dealing with an exponential factor. So share with somebody, leave a comment. Let's see your thoughts on this question. Juxtaposed with the episode number 8. We are all learning together. Let's learn and grow together. Share, comment, subscribe, and bye-bye.